Good morning, everyone. My name is Dave Lauer, and I'm CEO of Enviromix. It's my pleasure to introduce you to Freddie Cade, Enviromix's Director of Regional Sales. He'll be addressing you on how cyclic aerated mixing delivers substantial energy savings. Freddie, I'll turn it over to you.
Good morning, everyone, and thank you for your time today. I'm excited to be here to introduce you to one of our innovative products. My name is Freddie Cade, and I am a Director of Regional Sales at Enviromix. A few housekeeping items before I get started. First, we will be emailing certificates of attendance to all who attend this live webinar. We will be taking questions at the end of the presentation. So if you think of any during the discussion, please use the Q&A feature at the bottom of the screen to submit them. My camera will be off during the presentation to provide you the best audiovisual experience today. So with that behind us, let's get started. I would like to introduce you to our cyclic aerated mixing system, better known as CAMix. With CAMix, our customers can expect 50% or greater reduction in energy usage compared to conventional continuous aeration. Unmatched turn-down capability resulting in the elimination of over-aeration, and substantially reduced blower size, which decreases capital expense. All of this is accomplished through the delivery of proportional air volumes that uniformly mix and aerate areas of the tank in sequence. Over the course of the next 20 minutes, my goal is to explain why you should consider CAMix, how it works, discuss a case study where CAMix is operating, where we apply the technology more broadly, and the benefits of using CAMix. Following that, I will answer a few questions as time allows. Many, if not all of you, are familiar with the 10-state standards published over 70 years ago. These standards and publications, such as WEFSMAP 8, have provided the wastewater community with guidelines to design treatment facilities. These standards have acted as rule of thumb for engineers, but depending on the application and the technology, they may not be appropriate to meet project-specific needs because they are generic, not well-defined, frankly outdated, and not as relevant to present-day technology or applications. For example, take 10-state standard and MOP8 recommended guidelines for aerated mixing rates for EQ, sludge holding, and channels. As a designer, one should question these guidelines and ask, does the type of aeration device matter? These guidelines don't differentiate between the different types of aeration devices. Does the organic loading to the process make a difference in the air requirements? These guidelines don't vary the air requirements proportional to organic loading rates. What about basin geometry? Does that affect these guidelines? Once again, minimum, maximum, or variable depth is not a consideration of these guidelines. We will show how CAMix can be a smarter solution using today's best available technology. Aeration represents one of the most energy-intensive operations in municipal wastewater treatment, accounting for 50 to 90% of a treatment facility's total energy costs. In a typical diffused aeration application, air is delivered by aeration blowers through a diffused aeration system, which provides both oxygen and mixing to support the particular treatment process. Diffused aeration is widely used throughout treatment facilities for many applications, including equalization, activated sludge bioreactors, channels, sludge holding tanks, and aerated sludge tanks, where the function of the diffused aeration system is to supply oxygen while also mixing the reactor contents. In some instances, the airflow required to satisfy mixing exceeds the airflow requirements to meet the oxygen demand of the application. This results in what is commonly referred to as a mixing limited situation. Mixing limited conditions commonly result in over-aeration and wasted energy. A plant is usually mixing limited from the date of startup because they are not at their design 30-year loading on day one. Utilizing diffused aeration to transfer oxygen capitalizes on the strength of the technology. This is what the technology does best. Though diffused aeration can also mix effectively, it does so at a relatively high energy cost and is therefore not the best technology for a mixing limited application. By understanding the challenges of aligning oxygen supply and satisfying mixing needs, EnviroMix is challenging the status quo by introducing a solution to fill a gap in the marketplace that is more efficient without compromising performance, addressing mix-limited applications in an energy-efficient manner. The solution is respectful of the intentions of the industry standards while offering the design engineer and utility owner the flexibility to customize the airflow to meet the specific needs of the application. The professionals at EnviroMix took their expert understanding of mixing with proprietary pneumatic valve module control and combined it with a background in aeration and biological process and used that nexus of expertise to develop a new product unlike anything in the market. CAMix Cyclic Aerated Mixing was born. CAMix utilizes EnviroMix's deep knowledge of aeration and biomix, the proven and widely used compressed air mixing system. Before we introduce CAMix to you, let me review biomix, as CAMix shares some operational similarities which you will recognize. So how does our compressed air mixing system work? The biomix system provides uniform mixing of tank contents at a fraction of the energy consumption of mechanical mixing by firing programmed short duration bursts of compressed air in areas of the tank in sequence through nozzles that are located near the tank floor. The biomix system works by utilizing a central compressor system to produce the necessary air volume to meet the mixing air demand. The compressor charges a receiver tank for air storage, which buffers system demand. The receiver tank supplies air to the valve module, which controls the firing parameters of pressure, frequency of discrete mixing, duration of air release, and header firing sequence. Biomix utilizes patented engineered nozzles near the floor of the tank to generate large fluid displacing bubbles produced by short duration bursts of compressed air. Those air bubbles expand upward and outward without measurable oxygen transfer due to the characteristics of the large bubbles. Over the years, a common misperception of our biomix compressed gas mixing system has existed, that it is coarse bubble aeration and it transfers oxygen. Compressed gas mixing is not aeration, as it intermittently produces large fluid displacing bubbles, air volumes, in an area of a basin for a fraction of a second, 2 to 3 times a minute. As such, the small amount of air utilized for mixing and the large size of the gas volume results in negligible oxygen transfer. Therein lies the key misunderstanding. Leveraging EnviroMix's proven intermittent compressed gas mixing technology, CAMix introduces localized proportional air volumes to simultaneously and uniformly mix and aerate portions of a tank in sequence. So what exactly is CAMix and how does it work? The beauty of CAMix is that it operates on the same principle of cycling air to different portions of the tank sequentially. However, instead of using nozzles with high pressure compressed air, we use conventional fine or coarse bubble diffusers with low pressure air from a conventional blower. The air can either be supplied from a dedicated blower or from a centralized air supply that may be serving multiple different aerated processes. A proprietary valve module and controller then direct the air to the grids. Instrumentation feedback can be used to automatically adjust aerated mixing parameters such as DO. The air volumes both mix and aerate the individual zones. CAMix operation can be adjusted to provide complete tank mixing, partial mixing, or quiescent conditions in discrete zones or in complete tanks. As you can see from this graphic, the CAMix system is only operating in one zone at any given time. There is a slight overlap between zones to prevent deadheading the blower, but otherwise the sequence passes from one zone to the next. You can see currents in the non-actuated zones in the tank that show the larger zone of influence from the actuated zones. The zone of influence combined with a sequencing pattern and timing is what is used to ensure complete mixing throughout the tank. The scope of the supply for a CAMix system includes the aeration valve module that is mounted tank side and individual diffuser grids with coarse or fine bubble diffusers. The dedicated blower can be provided by EnviroMix, or air from a centralized air supply can be used. The aeration valve module, or AVM as we call it, is the brains of the CAMix system. The same proven air control valves used in the hundreds of biomix systems have now been adopted for low pressure air application. The plug-and-play control box is a completely engineered solution that includes an intuitive user interface and the logic needed to operate the air control valves located in the panel. The AVM can provide standalone control of the CAMix system. The AVM can also interface with an EnviroMix master control panel if the system is part of a larger EnviroMix solution, or directly to the plant SCADA for both monitoring and control. Moving on to a case study at the Beaufort Jasper Water and Sewer Authority, BJWSA, in Ocady, South Carolina, where CAMix is operating in a 187,000-gallon sludge holding tank with 1% at their Cherry Point Water Reclamation Facility. Beaufort Jasper Water and Sewer Authority provides drinking water to more than 150,000 residents. Collect and treat wastewater at their 8 water reclamation facilities. EnviroMix has partnered with Beaufort Jasper since 2016, reducing energy consumption and supporting sustainability effort. Beaufort Jasper experienced the performance benefits of EnviroMix's biomix compressed gas mixing technology and has come to trust our expertise and product reliability. Beaufort Jasper was first exposed to biomix at their upgraded and expanded Hardyville Water Reclamation Facility installed in a 1.5 million gallon equalization tank and the anoxic BNR selectors. Biomix was also installed at their Port Royal facility in a 2.8 million gallon equalization tank. While the Hardyville and Port Royal facilities used biomix, Beaufort Jasper was introduced to CAMix at their Cherry Point facility. At Cherry Point, the waste-activated sludge holding tanks were operated with a conventional coarse bubble aerator designed to provide enough air to completely mix the entire tank, prevent deposition of solids, and satisfy WES oxygen demand. As is common with most WES holding tank applications, the process is mixing limited, meaning the volume of air necessary to mix the tank contents is far greater than the volume of air required to satisfy the oxygen demand. Knowing that the utility would benefit from a more energy-efficient solution, EnviroMix proposed using the Cherry Point as a testing site for an innovative intermittent aerated mixing system, and they enthusiastically agreed. At Cherry Point, CAMix provided uniformly mixed conditions without wasting energy and required 65% less power than the conventional coarse bubble aerated mixing system, with blowers that were a third of the horsepower. Pleased with the results, Beaufort Jasper purchased the first CAMix Cyclic aerated mixing system. The CAMix system replaced the conventional coarse bubble aeration system with 3 independent aeration grids that were intermittently and sequentially aerated. With a dedicated 30 horsepower blower in operation, the CAMix aeration valve module provided 10 minutes of air-on aeration of an individual grid and 20 minutes of air off. Though only a third of the 75-foot long by 25-foot wide WES holding tank was aerated at any given time, the mixing currents within the tank ensured uniformly mixed conditions with a coefficient of variations of less than 10%. Furthermore, positive aerobic conditions were maintained to keep the WES fresh as continuously positive ORP and DO were achieved. This was accomplished despite CAMix providing only a third of the air of conventional aerated mixing. The existing system provided aerated mixing at the 10-state standards rate of 30 SCFM per 1,000 cubic feet of tank volume, or 750 CFM. The CAMix system provided the same active grid mixing intensity of 30 SCFM per 1,000 cubic feet of tank volume, but this represented a total volumetric air rate of only 10 SCFM per 1,000 cubic feet, or 250 CFM. This resulted in energy savings of 33.6 brake horsepower and annual cost savings of $25,000. So where can a CAMix system be used, and what are the benefits? A CAMix system can be used in any wastewater treatment plant where mixing is required, but the process only needs a small amount of oxygen to meet the biological demand. The most popular applications are channels, sludge holding, aerated sludge tanks, and equalization tanks. However, we're guessing that you're probably thinking of one or two other applications at a facility you're working on where this might just be the solution you're looking for. The most obvious benefit of CAMix is the reduction in both capital expenditure and operating expenditure. By cycling the air from one zone in a tank to the next, instead of applying it to the entire tank 24/7, there's a reduction in energy consumption by more than 50% in most applications. Additionally, the size of the blower will be dramatically and similarly reduced. For example, instead of a duty and standby 100 horsepower blower, you'd be looking at a duty and standby 25 horsepower CAMix blower, resulting in capital savings for the blower package and electrical service. Finally, during operation, there's unmatched turn-down capability, which results in the elimination of over-aeration and wasted energy. The example shown in the graphic to the right shows a typical system designed with a conventional approach of 30 S per K. To continually aerate the entire tank, the blower must be sized for 1,000 SCFM. However, with CAMix, the air is directed to individual zones with the airflow rate designed around an equivalent 30 S per K per zone, which is only 250 SCFM. The result is substantially smaller blower size operating at a lower horsepower. Other benefits of CAMix are related to process optimization. The aerated mixing parameters allow for flexibility such that an operator can adjust parameters manually or use instrumentation feedback to automatically change parameters. An example of this is using dissolved oxygen readings to reduce aeration intensity or complete stop mixing to prevent over-aeration. CAMix uses bottom-up mixing to provide options for plants for a variety of mixing objectives. EnviroMix guarantees uniform mixing with an on-site performance test during startup period. CAMix offers straightforward operation, giving operations and maintenance staff peace of mind. With the intuitive controls, you can set it and forget it, especially during times of steady-state operation. With no mechanical or electrical components in the wastewater, the system is low maintenance with trouble-free operation. CAMix offers unparalleled flexibility for implementation and operation. CAMix systems are compatible with any geometry of tanks, including those with hopper bottoms, since the aeration grids can be located at different elevations and operate in sequence to prevent issues with pressure differences of different diffuser depth. CAMix solves the problem of maldistribution of air and solid deposition solids in the cone of the tank, which results in reduced tank capacity. CAMix is also able to operate at variable water depth. The system can use dedicated blowers, share blowers from different applications, operating at different air rates and depth, such as a sludge tank, an equalization tank, or a side stream of air from an existing air main. CAMix is adjustable to a number of different monitoring and control options, including optional DO, ORP, and/or TSS controls. So, in summary, the key points you should remember from this presentation today are that CAMix cyclic aerated mixing delivers proportional air volumes that uniformly mix and aerate areas of the tank in sequence. CAMix delivers unlimited turn-down capability, eliminating over-aeration, especially for EQ, sludge holding, channels, and aerated sludge applications. CAMix delivers 50% or greater reduction in energy usage versus conventional continuous aeration. And finally, CAMix delivers substantially reduced blower size, decreasing capital expense. That concludes my presentation today. As I said earlier, Follow-up email will be sent to all participants with a certification of completion and additional information about CAMix. When you exit out of this webinar, please take a moment to complete the short survey that will provide us feedback and let us know if you'd like someone to contact you about any of our Enviromix products. Thank you so much for your time and attention. Our engineers are available to discuss your next CAMix application.
Thank you, Freddie, for a very informative presentation. Now let's take a look through the questions that were submitted via the Q&A feature. We're going to answer a few of the questions now, and those that we don't get to will be answered via email, either by Freddie or another member of our team. Okay, let's take a look at the first one. Can a new Enviromix mixer system be combined with an existing blower-driven coarse bubble aeration system in an aerobic digester? The way I interpret this question is, can an Enviromix biomix compressed gas mixing system be combined with an existing blower-driven coarse bubble aeration system? If we look at adding biomix compressed gas mixing to a diffused aeration system, that gives you the ability to decouple aeration from mixing, but the biomix requires its own standalone high pressure, typically 100 psi compressor versus, let's say, a 10 or 15 psi low pressure blower. So that's one aspect. If we're talking about, can CAMix replace, let's say, coarse bubble aeration system in an aerobic digester, it definitely can. We would have to look at the oxygen demand of the process. We would have to look at the capacity of the existing blowers, if they could be operated by VFDs at a lower output speed, given that more likely they're oversized for the particular application. Okay. Have we ever done, or have we ever applied CAMix in a suspended attached growth process, such as an MBBR or an IFAS system? We have not. We have looked at our alternative compressed gas mixing technology, biomix, with suspended growth, IFAS style media or MBBR media to mix, because many times those types of applications operate at a fairly high aeration intensity, both to mix, but also transfer oxygen deep into the biofilm of the system. But there would be a potential. We may want to follow up with you for doing a pilot or demonstration to see if CAMix would be an appropriate solution for that. Okay. Freddie, I'm going to turn it over to you to take a couple more of the questions, if you don't mind.
Thank you, Dave. When would you use biomix versus CAMix? Great question. Biomix offers energy efficient mixing solution when oxygen transfer is not required. This will be primarily in BNR mixing applications, channels, sludge holding, and the like. CAMix is better suited for aerated mixing applications where you need to satisfy a small biological oxygen demand, such as certain equalization tank applications, wild sludge holding tanks, really any mixing limited application. Should we take one more question, Dave? A couple more questions. What is the max solid concentration that can be mixed using CAMix? As typical when using any diffused aeration system, solids content can be as high as 2% in the case of a sludge application. When facing mixing applications with much higher solids, we would combine our biomix technology with diffused aeration to mix up to 8% solids content, as biomix can efficiently mix higher solids concentration at lower energy input. Let's take one more. Is there a preference regarding the type of aeration device used with CAMix? That's a great question. CAMix can incorporate fine or coarse bubble aeration devices. Fine bubble diffusers offer the most energy efficient oxygen transfer technology. Coarse bubble diffusers can be less maintenance intensive if they are of the non-clog variety, which is an advantage for plants looking to reduce their maintenance hours.
All right, Freddie, I think we'll leave it there, just to be respectful of everyone's time. Thanks for everyone for attending. As I said previously, we still have a number of questions in the Q&A that we didn't get to, but we will answer them via email. Thank you again, and everyone have a great day.